All right, let's take a look at another thing here. The next on our objective is how to find the inverse of a matrix. If A and B are any two matrices such that AB is equals to BA equals to identity, this don't forget that I explained the types of matrices we have. It's called identity. What do we mean by identity or unit matrix? When you have 1 0 0 1, are you getting it now? So if A and B are any two matrices such that AB is equals to BA equals to identity, then we say B is the inverse of A. You can also say reciprocal. Another word for inverse is reciprocal. So let's look at how do we find the inverse. The inverse of a matrix is usually denoted as A raised to power minus 1, and you read it as A inverse. A inverse, that's how to read inverse of A. A inverse. This A can be any letter. It can be B, it can be C, it can be capital letter Q. So just note that we denote it with what? Usually we denote it with A inverse. Thank you. So the next thing, I would have loved to go to the long process of finding inverse, but due to space on your phone, majority are complaining they don't have much space on their phone to download. It's not easy. So I'm going to look at the quicker method of finding the inverse of 2 by 2 matrix. So in finding the inverse of 2 by 2 matrix, you need to take note of 3 important steps. The first step, you need to interchange the elements in the leading diagonal. What do we mean by the leading diagonal? If I have, for instance, if I have A, B, C, D, if capital letter A is equals to this, if capital letter A is equals to this, I want to find the inverse. Let's say A inverse. That's what I'm looking for. For me to find the A inverse, the first thing I said, you interchange the elements in the leading diagonal. What are the elements in the leading diagonal? This is leading diagonal. And what are the elements there? That is A and what? A and D. So interchanging means we have D coming up and here we go to. You interchange it. You take D here, you bring A here. So that's the first thing. Interchange the elements in the what? Leading diagonal. The second thing, you now change the sign. See the second diagonal. This is the second diagonal. You change the sign. This is leading diagonal. So you change what? The sign. Now, what I have here, I have B. It's going to be minus B. What I have here is C. It's going to be minus C. Do you get that now? So this first step is what? Interchange the elements in the leading diagonal. And the second step is what? You change the signs in the second diagonal. Do you understand that now? You change the what? The sign in the second diagonal. Now, the last step is you multiply the results. Multiply the results, the resulting matrix, by the determinant of the original one. Now, the resulting matrix, this is resulting matrix. This is what we have now. If we are to take the determinant of this, our A inverse is going to be, we multiply this by the what? By the reciprocal of the determinant. Are you getting my point? Now, what is the determinant of this? To get the determinant, we say leading diagonal, multiply it minus the second diagonal. So the leading diagonal will be A times D. That is what? So the reciprocal will be 1 all over A times D. That's what? AD. Minus the second diagonal, B times C. That is what? BC. Do you understand? So the determinant is what we are going to multiply, the reciprocal of the determinant. So I'm going to take a sample for you to see how it's done. Now, provided that your A, D, and BC is not equals to 0, this thing here must not be equals to 0. If it is equals to 0, we don't have any inverse. Don't forget, whenever the denominator is equals to 0, we say it is undefined. 1 all over 0, you cannot press it. If you press it in calculator, it will tell you syntax error or math error. It is called undefined. So you should take note that provided this is not equal to 0, once this is 0, that means such matrix does not have an inverse. Do you get that now? So let me take example under that. Don't forget the step. This first one is interchanging the what? The elements in the leading diagonal. The second one is what? Change the signs of the elements in the second diagonal. And the third one is multiply the resulting matrix by the reciprocal of the determinant of the original matrix. So let's look at some examples under that. Now, we want to find the inverse of the following matrices. Find the inverse. The first one, we want to find minus 3, 5, 6, 8. We want to find the inverse. So let's say A is equals to this. So we want to find A inverse. So to find the A inverse in this question, the first thing, our A inverse is going to be 1 all over the determinant. What is the determinant of this? That's minus 3 times 8 minus the second diagonal. That's what? 6 times 5. So the next thing is what? Don't forget, we are going to interchange the leading diagonal. So this is leading diagonal. What I have here is minus 3 and 8. So 8 will come here, minus 3 will go. So I have 8 here and I have minus 3 here. The next thing, I will change the sign. Whatever sign I have in front of the second diagonal, I will change it. But here I have 6, it will turn to minus 6. Here I have 5, it will turn to minus 5. If you have minus 5 there, it will turn to plus 5. Just change the sign in front of it. Do you get that now? So my A inverse now is going to be 1 all over minus 3 times this. That will give me minus 24 minus 6 times 5 will give me 30. That's minus 30 all over 8 minus 5 minus 6 minus 3. So what I need to do is just to add this one to get my final answer. So to add that one now, what will I have? I will have my A inverse will be equals to 1 all over minus 54 bracket 8 minus 5 minus 6 minus 3. So that is the final answer. Do you get that now? So that's how to find the inverse of matrix. So let's look at the second one. I want to find the inverse of the second one. The second one is we have to find the inverse of minus 4 2 minus 6 3. So let's say B equals to minus 4 2 minus 6 3. Do you get that now?